Welcome to these gentle, soothing stories for sleep. I'm so glad you are here. Whether you're preparing to drift off to sleep, relaxing after a long day, or simply seeking a quiet companion, you've come to the right place. Tonight, we will begin a journey into one of humanity's most persistent dreams, exploring the soft, shimmering question of time itself. We will ask, could we really reverse the past? Before we begin, I'd love to know where you're listening from tonight, or how your day was. Please leave a comment below. Wherever you are, I hope you are feeling comfortable, relaxed, and ready to explore something gentle yet extraordinary. And if you find these soothing scientific journeys interesting, pleasant, or even just wonderfully weird, please consider liking this video and subscribing to the channel. It helps more souls who are searching for peace find their way here. Imagine, just for a moment, that you are holding an old photograph. The paper is smooth and slightly cool to the touch, its edges softened by the countless hands that have held it over the years. It carries a faint, dry scent, the smell of paper and memory, of a time sealed away behind a thin layer of silver and chemicals. The image itself is a ghost, a silent echo of a summer afternoon long since past. The light in the picture is golden and hazy, just as you remember it, illuminating a face you love, frozen in a smile that has not aged a single day. You can almost feel the warmth of that sun on your own skin, almost hear the distant sound of laughter that the photograph cannot contain. And as you gaze into this captured moment, a quiet, profound question rises within you, a whisper from the deepest part of your heart. What if you could do more than just look? What if you could feel the gentle breeze of that day, smell the freshly cut grass, and step back, just for a moment, into the warmth of that lost embrace? This yearning is not yours alone. It is a universal human dream, a melody of longing that has echoed through every culture and every generation. It is the dream of reversing the past, of unwinding the great, unyielding clock of the universe. This feeling of time as a relentless, forward-moving force is so intuitive that we rarely stop to question it. We see it in the world around us, in the cycle of seasons, in the slow, inevitable aging of our own bodies. Physicists have a name for this one-way journey. They call it the arrow of time. It points unfailingly from the past, through the present, and into the future. But to truly understand this arrow, we must first change our perception of time itself. For much of human history, we imagine time as a kind of universal clock, ticking at the same rate for everyone, everywhere. It was a grand, invisible river that carried everything along in its current. Then, in the early 20th century, a mind named Albert Einstein completely reshaped our understanding. He revealed that time is not separate from space. Instead, they are woven together into a single, four-dimensional fabric called space-time. 3 dimensions tell us where something is in space, its length, width, and height. The 4th dimension tells us where it is in time. So, your life is not just a series of moments. It is a long, continuous line drawn through this fabric of space-time, a world line that traces your path from birth until this very moment. You are always moving along this 4th dimension, surfing the forward crest of the present. But why can we only move forward? Why can we retrace our steps in space, walking back to a place we have been, but never retrace our steps in time, returning to a moment that has passed? The answer lies in one of the most fundamental and powerful laws of the universe, the second law of thermodynamics. It sounds complex, but at its heart is a very simple and familiar idea, the idea of entropy. Entropy is, in essence, the measure of disorder, randomness, or chaos. The second law states that in any closed system, like our universe, the total amount of entropy will always tend to increase over time. Imagine a pristine, perfect glass sitting on a table. It is a state of high order, low entropy. If it falls and shatters on the floor, it breaks into 1,000 pieces, scattered randomly. This is a state of high disorder, high entropy. You have seen this happen. But have you ever seen 1,000 scattered shards of glass spontaneously leap from the floor and reassemble themselves into a perfect glass? Of course not. That would be a decrease in entropy, a violation of this fundamental law. This is the arrow of time at its most visceral. An egg unscrambles itself no more than a shattered glass can mend its own wounds. The universe, as a whole, is like that falling glass. It began in a state of incredibly low entropy, a hot, dense, highly ordered point, and ever since the Big Bang, it has been expanding, cooling, and becoming more and more disordered. The forward flow of time, the very reason yesterday is different from today, is the universe simply following its natural tendency to move from order to chaos. Our memories, those precious photographs in our minds, are our own personal, imperfect time machines. They allow us to travel back in our minds, to revisit the emotions and sensations of a moment, even if our bodies must remain firmly anchored in the ever-advancing present. They are beautiful, haunting echoes from a past that seems forever out of reach. But is this river truly impassable? Is the arrow of time so absolute, so unbreakable? Are there perhaps whispers in the deepest laws of physics, strange and subtle currents in the river of space-time, that suggest this one-way journey might, just might, not be the only direction possible? Have you ever had a day where time seemed to bend and stretch, to play tricks on your perception? Think of a long, quiet afternoon with nothing to do, where you watch the clock and every tick of the second hand feels like a lifetime. The minutes drag on, heavy and slow, as if caught in honey. Now, contrast that with a fleeting, joyful hour spent with someone you love. A conversation so engaging that when you finally look at the clock again, you are stunned to find that hours have vanished in what felt like mere moments. This personal, subjective experience of time's elasticity is more than just a feeling or a trick of the mind. It is a profound clue about the true nature of time, a secret that Einstein unlocked, not with emotion, but with the elegant language of mathematics. He showed us that the river of time does not flow at the same steady pace for everyone. Its current can quicken and slow, and the rate at which you journey into the future is not as fixed as you might think. This extraordinary idea is called time dilation, and it is a cornerstone of Einstein's special theory of relativity, which he published in the year 1905. The theory is built on two simple but revolutionary ideas. First, that the laws of physics are the same for everyone, no matter how they are moving, and second, that the speed of light in a vacuum is a cosmic speed limit, constant and absolute for all observers. From these postulates, a strange and wonderful consequence emerges. The faster you move through the 3 dimensions of space, the slower you move through the 4th dimension of time. Imagine 2 twins, born on the same day. One stays on Earth, living a normal life, while the other becomes an astronaut and embarks on a fantastic journey to a distant star in a spaceship that can travel at, say, 99% the speed of light. For the astronaut twin, the journey out and back might feel like only a few years. They would eat, sleep, and age at a normal rate inside their ship. But upon returning to Earth, they would be met with a shocking reality. While only a few years had passed for them, decades, perhaps even centuries, would have passed for their twin on Earth. The stay-at-home twin would be old, or perhaps long gone, a memory from a distant past. This isn't science fiction. It is a real, measurable prediction of physics. The clocks on our GPS satellites, which are moving very fast relative to us on the ground, have to be constantly adjusted to account for this very effect of time dilation. Without these corrections, our navigation systems would fail within minutes. But Einstein's vision didn't stop there. A decade later, he unveiled his general theory of relativity, which gave us an even deeper understanding of time's flexibility. He showed that it is not only speed that can alter the flow of time, but gravity itself. He imagined that the 4-dimensional fabric of space-time is not flat, but can be warped and curved by the presence of mass and energy. Think of stretching out a large, rubber sheet, like a trampoline. This sheet represents space-time. If you place a light object, like a marble, on it, it creates a tiny dimple. If you place a heavy object, like a bowling ball, on it, it creates a deep, significant curve in the fabric. This curvature is what we experience as gravity. Now, imagine rolling the marble near the bowling ball. It doesn't fall straight down. It follows the curve in the sheet, appearing to be attracted to the larger mass. This is how gravity works. But this warping of space-time doesn't just affect the path of objects in space. It also affects their journey through time. The deeper the gravitational well, the more space-time is curved, and the slower time itself flows. A clock at sea level, being closer to the center of the Earth's mass, will tick ever so slightly slower than a clock on top of a mountain. The difference is infinitesimal, far too small for us to ever notice, but with incredibly precise atomic clocks, scientists have measured it. Time literally flows more slowly in your basement than it does in your attic. This means that gravity, the silent, invisible force that holds us to the Earth and keeps the planets in their orbits, is also a gentle, ever-present sculptor of time itself. Every step we take, every breath we draw, is a passage through a subtly different temporal flow, governed by the silent dance of mass and energy across the cosmos. If time can be stretched by speed and bent by gravity, if its flow is not absolute but relative, it opens up a breathtaking question. If we can curve the fabric of space-time, could we, theoretically, curve it so much that it bends back on itself? Could we follow a path through this warped landscape so profound, so extreme, that it forms a loop, leading us not to a new place in space, but back to a moment that has already been? Imagine standing on a vast, open plain, with the horizon stretching out in every direction. If you were to pick a direction and walk in a perfectly straight line, you would expect to walk forever into the unknown, always moving further from your starting point. But what if your world wasn't a flat plane? What if you were, unknowingly, standing on the surface of a colossal sphere, like our own Earth? You could walk in what feels like a perfectly straight line, never turning. Yet after a long and patient journey, you would find yourself looking upon a familiar landscape. You would have arrived back where you began, not by retracing your steps, but by completing a great circle. The path was finite, yet it had no end. Now, hold that strange and beautiful idea in your mind, but instead of a journey through space, imagine a journey through time. Imagine a path through the fabric of space-time that, no matter how far you travel forward, always brings you back to a moment you have already lived. This is not just a poetic fancy. It is a stunning possibility that arises from the very equations Einstein gave us to describe our universe. These theoretical pathways are known in physics as closed time-like curves, or CTCs. They are, in essence, loopholes in the geometry of space-time, regions where the distinction between past and future becomes blurred, and a path can be traced that ends in its own beginning. The possibility of their existence was first discovered by a brilliant mathematician and close friend of Einstein, named Kurt Gödel. In the year 1949, Gödel found a new and deeply unsettling solution to Einstein's equations of general relativity. He imagined a universe that wasn't just expanding, but was also rotating. In such a universe, the sheer rotational force would be so immense that it would literally drag the fabric of space-time along with it, a phenomenon known as frame dragging. Gödel showed that if the universe was spinning fast enough, this dragging effect could become so extreme that it would tilt the very structure of past and future. It would tilt the light cones, the boundary of what any object can influence in its future so much that they would loop back on themselves, creating pathways that would allow a sufficiently advanced traveler to journey into their own past. It was a mathematically perfect solution, and it showed that there was nothing in Einstein's theory, as it was written, that explicitly forbade this kind of temporal looping. Gödel's rotating universe is not the one we observe. Our universe is expanding, but it does not appear to have this kind of overall rotation. However, other physicists have found other theoretical scenarios that could produce the same effect on a more local scale. One such idea involves an object of immense density and length, spinning on its axis at incredible speeds, close to the speed of light. Imagine an infinitely long cylinder, more massive than a star, rotating billions of times per second. The Dutch mathematician Willem Jacob van Stockham first explored this idea in 1936. The extreme rotation of such a colossal object would warp space-time around it so violently that it would create a vortex, a whirlpool in the river of time. A spaceship carefully navigating a specific path around this spinning cylinder could find itself caught in this temporal current, arriving back at its starting point in space, but at a moment in time before it had even begun its journey. These cosmic objects are, for now, purely theoretical constructs. We have never seen one, and the engineering required to build one is far beyond anything we can conceive. But their importance is not in whether we can build them. It is in what they tell us about the fundamental rules of our reality. They are like strange, exotic flowers that have bloomed in the garden of mathematics, showing us that the landscape of space-time might be far stranger and far more wonderfully curved than our everyday experience suggests. They force us to contemplate the idea that our universe is not a simple, straight line, but a vast and intricate tapestry, woven with threads of time and space. And if that is true, are we merely tracing a single straight thread, completely unaware of the grander pattern that might loop and weave and fold in upon itself in ways we can barely begin to imagine? But this beautiful, geometric possibility raises a deeply troubling question, a phantom that haunts every dream of traveling to the past. If such a cosmic loop existed, and you could follow its path back to a time you have already lived, what would happen if you were to meet your past self? What would happen if you interfered? What logical tangles, what impossible paradoxes await a traveller in these theoretical gardens of time? There is a question that coils itself around every story of time travel, a soft and unsettling whisper that challenges the very logic of the endeavour. It is a question that has been asked in countless books and films, the ghost that haunts the machine. What if you could travel back in time to the days before you were born, find your own grandfather as a young man, and, for some reason, prevent him from ever meeting your grandmother? The logic seems simple at first. If they never meet, they never fall in love, they never have children, and one of those children is never your parent. And if your parent is never born, then you, in turn, are never born. But here, the story begins to unravel, to eat its own tail, like the ancient symbol of the Ouroboros. For if you were never born, then you could never have grown up, become a time traveller, and stepped into a machine to journey into the past. And if you never went into the past, you could never have interfered with your grandfather. And if you never interfered, he would have met your grandmother, and you would, after all, have been born. The story collapses into a perfect, impossible contradiction, a statement that is true only if it is false, and false only if it is true. This is the famous grandfather paradox, and it represents the most significant barrier to the idea of travelling to and altering the past. It suggests that such an act is not just physically difficult, but logically impossible, a violation of the fundamental principle of cause and effect that underpins our entire understanding of reality. This principle, known as causality, simply states that an effect can never happen before its cause. The falling of the glass must always come after it has been dropped. The sound of thunder must always follow the flash of lightning. A journey into the past that changes the conditions of its own beginning seems to tear this principle apart, creating a timeline that invalidates itself, a story that erases its own author. It feels instinctively wrong, as if the universe itself would not and could not permit such a logical wound to be inflicted upon its history. But perhaps there is another way to look at this puzzle. Perhaps the problem lies not with the journey, but with our assumption that we have the freedom to change things. This leads to a different kind of temporal story, one not of contradiction, but of destiny. It is called the predestination paradox, or sometimes the bootstrap paradox. In this model, any journey to the past and any actions the traveller takes were always a part of history. The traveller does not change the past, they fulfill it. Their presence and their actions are the very cause of the future that they remember. Imagine a man who is haunted by the memory of a tragic fire in his childhood home. He becomes a scientist, invents a time machine, and travels back to the night of the fire, intending to stop it. He arrives in the darkness, carrying an old lantern. As he moves through the house, he stumbles, accidentally knocking over the lantern, which spills its oil and starts a small flame. Horrified, he watches as the flame grows into the very blaze that he had travelled back in time to prevent. His attempt to change the past was, in fact, the cause of the event itself. He was not a disruptor of history, but its unwitting agent. This creates a perfectly stable, self-consistent loop in time. There is no contradiction. Everything happens as it was always meant to happen, with the future influencing the past, just as the past influences the future. This idea also gives rise to a fascinating puzzle about the origin of things. Imagine you are a great admirer of Shakespeare. You travel back in time with a complete collection of his plays, meet him as a young, unpublished writer, and give him the book. He then simply copies the plays and publishes them under his own name. They become the famous works that you grew up with, the very works that inspired you to make your journey. The loop is complete and consistent, but it begs a perplexing question. Who actually wrote Hamlet? The information, the plays themselves, seems to have no origin. It is an idea, a story, that exists only within a timeless, self-creating loop. Does the universe, then, have some deep, underlying mechanism to protect itself from logical inconsistencies? Is the principle of causality so fundamental that it would either force our actions to conform to a pre-written history or simply forbid the creation of paradoxes altogether? Are we just characters in a grand story that must remain coherent, no matter how we try to edit the pages that have already been written? Or is there another, even more startling possibility? Perhaps the universe resolves this puzzle not by forbidding the journey, or by locking the traveler into a pre-written script, but by changing its very structure in response to their actions. What if every choice, every change, does not rewrite the old story, but instead begins a brand new one? What if every attempt to alter the river of time simply causes it to branch into two? Think back, for a moment, to a significant choice you made in your life. Perhaps it was the decision to move to a new city, to accept a certain job, or even just to speak to a stranger who would later become a friend. In that moment, you stood at a crossroads, a fork in the path of your own timeline. You chose one direction, and your life unfolded from there. But have you ever found yourself wondering, in a quiet moment, about the path not taken? What became of that other road? Is there a version of you, a shadow self, still walking down that other trail, living a life shaped by a different choice? This feeling of infinite, branching possibilities is not just a poetic metaphor. It is the central idea behind one of the most staggering and beautiful solutions to the paradoxes of time travel, a solution that suggests the universe is vastly larger and more complex than we could ever have imagined. It asks us to imagine not a single river of time, but an infinitely branching delta, a garden of forking paths. This idea comes to us from the strange and counterintuitive world of quantum mechanics, the science of the very small. In the 1950s, a young physicist named Hugh Everett III was wrestling with a puzzle at the heart of quantum theory. The theory predicted that a particle, like an electron, can exist in multiple states at once, a condition called superposition. It is only when we measure it that it seems to choose a single state, a single reality. Everett proposed a radical and elegant solution. What if the particle doesn't choose at all? What if, at the moment of measurement, the entire universe splits? In one universe, the particle is in state A. In another, parallel universe, the particle is in state B. Every quantum event, every tiny choice, from the decay of an atom to the firing of a neuron in your brain, causes reality itself to branch, creating a near infinite number of parallel worlds. This is the many worlds interpretation. It suggests that somewhere, a version of you exists who did not move to that new city, who turned down that job, who walked past that stranger without a word. Every possible outcome of every event is playing out in its own separate, equally real universe. Now, let us see how this grand, branching cosmos solves the grandfather paradox. Imagine you build your time machine and journey back to prevent your grandfather from meeting your grandmother. In the many worlds model, you do not arrive in your own past. Your arrival itself is a quantum event that causes the timeline to split. You step out into a new, parallel universe, one that is identical to your own up until the moment of your arrival. In this new timeline, you are a traveler from another reality. You are now free to do whatever you wish. You could, indeed, Prevent the man who is this universe's version of your grandfather from meeting the woman who is its version of your grandmother. The consequence is that, in this new branch of reality, you will never be born. But this has absolutely no effect on you, the traveler. Your own existence is secure, because you came from the original, unaltered timeline, the one where your grandparents did meet, and you were born, and you built a time machine. The paradox vanishes completely. You have not rewritten history, you have simply created a new one. You are like a visitor who has stepped out of one river and onto the bank of a newly formed stream. The original river continues to flow, unchanged by your departure. The catch, of course, is that you can never go home. Your journey is a one-way trip into this alternate reality that you have created. You would be, in a sense, an orphan of time, a refugee from a universe you can no longer reach. This idea is both terrifying and liberating. It means there are no wrong choices, because every choice is made somewhere. It means that every possibility is realized. But it also paints a picture of a cosmos of almost unimaginable extravagance, a near infinite number of universes being created every single moment. Ponder for a moment the sheer scale of it. An ever-expanding multiverse filled with countless versions of yourself, each living out the consequences of a different turn. Is this a comforting thought, a grand tapestry of infinite experience, or is it a profoundly lonely one, knowing that you are forever separated from all those other selves, adrift in your own singular branch of reality? But is this immense, profligate creation of entire universes the only way to solve the puzzle? Is it possible that the universe is more economical? Perhaps there is only one timeline, one reality, but it is protected by a law that is gentler and yet more absolute than any paradox. A law, perhaps, that simply heals itself. Have you ever sat quietly with a warm cup of tea or coffee, and after stirring in the milk, watched the gentle, swirling eddies? For a moment, there is a chaotic, beautiful dance of currents and clouds. But if you just wait, the motion slowly subsides, the turbulence fades, and the liquid settles back into a state of calm, uniform stillness. The disturbance is gone, the memory of the spoon's passing erased, leaving only a placid surface. The system has returned to equilibrium. Now, imagine this simple, calming process on a cosmic scale. Imagine the fabric of space-time itself having this same innate tendency to settle, to resist disturbance, and to smooth over any potential ripples of contradiction. What if the timeline itself is resilient, protected by an inherent drive towards consistency? This comforting idea is known as the Novikov self-consistency principle, developed by the Russian astrophysicist Igor Novikov in the 1980s. It offers a profound and elegant resolution to the paradoxes of time travel without needing to invent an infinite number of universes. The principle is simple, yet powerful. It states that the laws of physics are such that any event that would create a paradox has a probability of exactly zero. In other words, it is impossible to create a temporal paradox because the universe itself will not allow it. The timeline is not just a passive stage on which events unfold, it is an active participant that ensures its own logical coherence. If you were to travel back in time with the explicit intention of committing the act described in the grandfather paradox, the universe would, in a sense, conspire against you. This doesn't necessarily mean some magical force would intervene. Rather, the mundane, probabilistic nature of the world would ensure your failure. Your time machine might malfunction and arrive a day too late. You might get stuck in traffic on the way to meet your grandfather. As you approach him, you might slip on a conveniently placed banana peel. Or perhaps your attempt to intervene would be the very thing that causes your grandparents to meet in the first place, locking you into the kind of predestination loop we have already explored. The key idea is that while you may have free will to try, the outcome is fixed. The laws of nature, from the grand scale of gravity to the quantum scale of probability, all work together to ensure that history is not, and cannot be, changed. The universe's story has already been written, and while a time traveler might be an unexpected character appearing in an early chapter, they cannot alter the ending. They can only play the part that was always there for them. This is a form of what physicists sometimes call cosmic censorship. It isn't a rule that prevents you from traveling in time, but one that senses what you are able to do once you get there. You can be a tourist in the past, an observer, even a participant, but you can never be a vandal. The timeline is robust, self-healing. Like a deep river, you can cast a stone into it and create a splash, but the current is too powerful, and it will quickly flow on, the disturbance vanishing as if it had never been, the fundamental course of the river unchanged. The consistency of history is preserved. This is a beautifully tidy solution. It requires no new universes, and it keeps our single, precious reality safe from logical collapse. But it comes at a philosophical price. If the outcome of our actions is predetermined to ensure consistency, what does that say about our own free will? Are our choices truly our own, or are we simply puppets of causality, dancing on the strings of a self-consistent timeline? Are we living a life of genuine choice and consequence, or merely acting out a script that must remain coherent, no matter how desperately we might wish to rewrite it? This vision of the universe is safe and orderly, but perhaps a little restrictive, a little too neat. It protects causality, but it feels as though it clips the wings of possibility. What if the secret to time travel is not hidden in these grand, overarching cosmic laws, but in something more fundamental still? What if the key is woven into the very fabric of information itself? Imagine you are standing on a cliff, looking out over a vast and placid ocean on a windless day. From your high vantage point, the surface of the water appears perfectly smooth, a great, blue sheet of glass stretching to the horizon. It seems solid, predictable, and calm. But then, imagine you could zoom in, closer and closer, until you could see the individual molecules of water. At that microscopic level, the surface would no longer be calm. It would be a chaotic, violent dance of particles, constantly colliding, bubbling, and churning. The serene smoothness was just an illusion of scale. What if the fabric of space-time, the very foundation of our reality, is the same? What if, on the smallest possible scale, the smooth, predictable river of time dissolves into a roiling, unpredictable foam of pure possibility? This is the strange and beautiful world revealed to us by quantum mechanics, and hidden within its whispers, we might find the faintest hint of a gateway to the past. In Einstein's theory of general relativity, we find the tantalizing mathematical possibility of wormholes, or as he and his colleague Nathan Rosen first called them, Einstein-Rosen bridges. These are theoretical tunnels, shortcuts through the fabric of space-time. Imagine space-time is a large sheet of paper. To get from one point on the paper to another, you would normally have to travel across its surface. But if you could bend the paper, folding it over so the 2 points touch, you could simply poke a hole through them, creating a bridge that is far shorter than the original path. A wormhole is a four-dimensional version of this, a tunnel connecting not just two different places in space, but potentially two different moments in time. For a long time, these were seen as mere mathematical curiosities, unlikely to exist in the real world. But when we weave together the physics of the very large general relativity with the physics of the very small quantum mechanics, a startling new picture emerges. At the most fundamental level of reality, a scale unimaginably smaller than an atom, known as the Planck scale, the smooth geometry of space-time is thought to break down. Here, quantum effects become so powerful that space and time are no longer well defined. Instead, reality is a chaotic, seething soup of energy, a quantum foam. In this realm, the universe is a blizzard of probabilities. Tiny, fleeting wormholes, smaller than the nucleus of an atom, may be constantly bubbling in and out of existence, connecting random points in space and time for infinitesimal fractions of a second before vanishing again. It is a world of pure potential, a place where the rules of causality and the steady flow of time might not be so absolute. Some physicists, like the brilliant Kip Thorne, have speculated that a vastly advanced civilization might, in theory, be able to reach into this quantum foam, capture one of these fleeting, microscopic wormholes, and somehow enlarge it to a macroscopic, human traversable size. Once stabilized, this tunnel would connect two different points in space-time. By leaving one end, or mouth, of the wormhole stationary and taking the other mouth on a journey at near the speed of light, time dilation would take effect. Time would pass much more slowly for the moving mouth. When it was brought back and placed next to its stationary twin, the two ends of the tunnel would now connect not just different places, but different times. Stepping through one mouth would be like stepping into a doorway that leads directly into the past of the other. This vision is perhaps the most scientifically plausible design for a time machine ever conceived. It does not violate any known laws of physics outright, and yet it rests upon a foundation that is profoundly alien to our everyday experience. It suggests that our solid, predictable world is nothing but a calm surface on a deep and turbulent quantum ocean. It implies that beneath the steady, reassuring tick of the clock, there is a chaotic, probabilistic realm where the very concepts of before and after, of here and there, are constantly being bent and momentarily broken. Our reality, it seems, might be haunted by the ghostly whispers of these fleeting gateways, these tiny, shimmering tears in the fabric of time. But even if we could reach out and grasp one of these quantum ghosts, what would it take to hold on? What impossible material, what substance born of dream, would be required to hold open the gates of time? Every great journey requires a bridge to cross an impassable chasm. But what if the chasm is time itself, and the bridge you need to build must be made of a material that defies the most fundamental laws of nature? Imagine holding two powerful magnets in your hands. You turn them so that their north poles are facing each other. As you slowly bring them closer, you begin to feel an invisible resistance, a strange and powerful cushioning in the air between them. The closer you push, the stronger this repulsive force becomes, an immense and stubborn power that seems to spring from nothingness, straining against the muscles in your arms. To hold them together requires a constant exertion of energy, a fight against a basic property of the universe. Building a stable gateway to the past, a traversable wormhole, would require a similar, but infinitely more profound, struggle against the nature of reality. The price for this gateway is a substance so strange, it has been named exotic matter. When physicists first began to study the mathematics of wormholes, they ran into a catastrophic problem. According to general relativity, any tunnel carved through space-time would be incredibly unstable. The immense gravitational forces involved would cause the throat of the wormhole to pinch off and collapse into a singularity, a point of infinite density, the instant it formed, or the moment anything tried to pass through it. It would be a bridge that disintegrates the very second you try to set foot on it. To hold it open would require some kind of cosmic scaffolding, a force that could push outward against the crushing pull of gravity. And this is where the need for exotic matter arises. This isn't just matter that is rare or from another planet. Exotic, in this sense, means something that possesses properties unlike any normal matter we have ever encountered. All the matter we know, from our bodies to the stars, has positive mass and a positive energy density. Its gravity is attractive. It pulls things together. Exotic matter, on the other hand, would need to have a negative energy density. It would, in effect, have a kind of repulsive gravity. Instead of pulling space-time inward to create a gravitational dimple like a bowling ball on a trampoline, it would push space-time outward, creating a bump. It is this anti-gravitational property that would be needed to line the throat of a wormhole, pushing against its tendency to collapse and holding the gateway open long enough for a traveller to pass through. For a long time, the idea of matter with negative energy was considered pure fantasy. But the strange rules of the quantum world once again provided a tantalizing clue. A phenomenon known as the Casimir effect, which was predicted in 1948 and has since been measured in laboratories, shows that it is possible. If you place two uncharged, parallel metal plates very close together in a vacuum, the space between them will have a slightly lower energy density than the space outside them. In a relative sense, the region between the plates has a negative energy density. The effect is real, but it is also infinitesimally small. To prop open a wormhole just 1 meter wide would require an amount of negative energy equivalent to the total energy output of 10 billion stars in an entire year, all concentrated into a tiny, stable region. We have no idea how such a substance could exist in a stable form, how it could be manufactured in such quantities, or how it could be handled. The universe, it seems, presents us with a beautiful, mathematically sound possibility for a time machine, and then it hands us a bill with an impossible price written on it. It shows us the lock on the door to the past, and then tells us the key is forged from a material that may not even be able to exist. Is this a cosmic test? A challenge to our ingenuity? Or is it a fundamental no trespassing sign? A gentle but firm law of nature that protects the past from the paradoxes of the future? The sheer, godlike scale of the challenge is enough to make one pause. So, let us set aside, for a moment, these grand and beautiful machines of curved space-time and impossible matter. What if we are thinking about the problem in the wrong way? What if time travel is not about sending a physical body, but about sending something far lighter, something as insubstantial as a thought? Could a message, a simple whisper from tomorrow, find a way to reach us today? Have you ever experienced a sudden, inexplicable flash of intuition? A feeling of déjà vu so vivid and overwhelming that it feels less like a trick of the mind and more like a genuine memory of a moment you have not yet lived. It is a fleeting, shimmering sensation, a feeling that you have stood in this exact spot, heard these exact words, felt this exact emotion before. Most of the time, we dismiss it as a momentary glitch in our brain's complex wiring. But what if it is something more? What if it is a faint echo, a subtle ripple in the fabric of time, a whisper from a future that is trying to speak to a past? What if the key to time travel is not to send a person, but to send a message? This approach, sending information rather than matter, elegantly sidesteps many of the most daunting obstacles we have encountered. A message has no mass, so it requires no exotic matter to hold open a gateway. A whisper cannot violate causality in the same way a physical person can, perhaps avoiding the grandfather paradox altogether. The idea of information breaking the light-speed barrier, and thus traveling back in time, has haunted the edges of physics for decades. One of the most famous candidates for this task is a hypothetical particle called the tachyon. The name comes from the Greek word for swift, and these particles, if they exist, would have a truly strange nature. According to Einstein's special relativity, it would take an infinite amount of energy to accelerate any object with mass up to the speed of light. This is the cosmic speed limit. But the equations also allow for a class of particles that are born already, traveling faster than light, and which could never slow down to below the speed of light. These are tachyons. From the perspective of some observers, a tachyon transmitting a signal would be seen to arrive before it was sent. It would be a message from the future. For years, physicists have searched for tachyons, but none have ever been detected. They remain ghosts in the mathematical machine, a beautiful but unproven possibility. A more modern and perhaps more subtle avenue for this kind of communication might lie in the strange phenomenon of quantum entanglement. Imagine two tiny particles, like electrons, that are created together in a special way so that their properties are linked. For example, they might have opposite spins. One is spin up, and the other is spin down. The strange part is this. According to quantum mechanics, until you measure them, neither particle has a definite spin. They both exist in a blurry, probabilistic state of being both up and down at the same time. But the moment you measure one particle and find it is spin up, you instantly know that the other particle, no matter how far away it is across the room or across the galaxy, will be spin down. The information seems to travel between them instantly, far faster than the speed of light. This spooky action at a distance, as Einstein called it, seems like a perfect way to send a message back in time. However, there is a catch, and it is a significant one. A rule known as the no communication theorem states that while the correlation between the particles is instant, you cannot use it to deliberately transmit information. The outcome of your measurement is always random, so you cannot encode a message in it. And yet, the mystery of this instantaneous connection across space-time remains one of the deepest puzzles in science. It is a whisper of a reality that operates outside our normal rules of time and space. Perhaps then, a message from the future would not arrive like a clear radio signal, but like something far more subtle and difficult to decipher. Could our own consciousness, our own minds, be the receivers for these temporal whispers? In the quiet of a library, surrounded by the silent stories of 1,000 lives, You might run your hand over the spine of an old book, and for a fleeting second, you might feel that you already know the story within, not because you have read it, but because its echo, its emotional shape, has somehow reached you across the years. Are our intuitions, our sudden creative insights, our moments of profound déjà vu, just stray signals from a future self, gentle nudges from a version of us who has already lived this moment? Are we all, in some small way, receiving faint, ghostly echoes from tomorrow, carried on the strange, invisible currents of the quantum world? This brings us to the most intimate and mysterious time machine of all, the one humming quietly inside our own heads. How does this remarkable organ construct the very feeling of past, present, and future? Close your eyes for a moment and just be. Feel the gentle rise and fall of your chest with each breath. Feel the weight of your body, the air on your skin. Can you feel the present moment? What does it feel like? Is it a single, sharp point in time, like the tick of a clock? Or does it feel more like a flowing current, a brief stretch of awareness that contains a little bit of the immediate past and a hint of the coming future? Our inner experience of time is not a series of snapshots, but a continuous, seamless melody. We hear a note of music not as an isolated sound, but as part of a phrase, held in our awareness with the notes that came just before it, and our anticipation of the notes that are about to follow. The American psychologist William James called this the specious present, the short duration of time that we perceive as being now. It is not an instant, but a small window, and it is within this window that our conscious reality unfolds. But how does the brain, a 3-pound universe of cells and electricity, create this profound and fundamental experience? The surprising truth is that our brain does not have a single central clock. There is no master pacemaker in our head, ticking away the seconds of our lives. Instead, our perception of time is a complex symphony, performed by many different sections of the brain's orchestra, all working together. For timing on the scale of milliseconds, crucial for things like understanding speech or playing a musical instrument, the brain relies heavily on the cerebellum, a densely packed region at the back of the skull. It is the master of precise motor timing, the conductor of our physical movements through time. Then, for the grand, sweeping rhythms of our lives, we have the circadian clock. Deep within the hypothalamus lies a tiny cluster of neurons called the suprachiasmatic nucleus. It acts as our body's master clock, synchronizing our sleep-wake cycles, our metabolism, and our hormones to the 24-hour rhythm of the Earth's rotation. It is the gentle, ancient drumbeat that ties our biology to the cosmos. But to create a personal history, a sense of a past that stretches back through our lives, the brain needs more than just a timer. It needs a storyteller. This is the role of our memory, and specifically, a seahorse-shaped structure deep in the temporal lobe called the hippocampus. The hippocampus doesn't just store memories, it tags them with contextual information, including when they happened. It is our brain's archivist, the part of us that places events in a sequence, creating the narrative of our life, our personal timeline. Without it, we would be adrift in an endless present, unable to connect one moment to the next. And finally, the experience of this timeline is not rigid. It is elastic, stretched, and compressed by our emotions and our focus. When we are in a state of fear or great excitement, our amygdala, the brain's emotional hub, goes into high alert. It directs the rest of the brain to absorb more sensory information, to create denser, richer memories. This is why frightening or thrilling moments often seem to unfold in slow motion. Conversely, when we are bored or disengaged, our brain processes less information and time seems to drag. Our attention, marshaled by the frontal cortex, acts like a zoom lens, focusing our perceptual resources and altering how much data we gather from each passing second. Our sense of time, then, is a beautiful and fragile construction, a story woven together by the intricate collaboration of circuits all across our brain. We are not merely passive passengers on a river of time that flows around us. We are active creators of our own temporal experience, moment by moment, within the quiet sanctuary of our minds. But if this is true, if our memory is the architect that builds our personal past, it raises a crucial and unsettling question. What happens when that architect is flawed? What happens when the blueprints are smudged and the memories are not perfect recordings, but hazy, fallible reconstructions? How reliable, then, is the very history we so deeply wish we could return to? Try, for a moment, to remember your 5th birthday party. Can you see it? Can you summon the memory with perfect clarity, as if replaying a high-definition video? For most of us, the image that comes to mind is something far more ethereal. It is a fuzzy, dreamlike collage of feelings and snapshots. You might remember the sweet, waxy smell of the candles on the cake, the rough texture of a party hat's elastic under your chin, or the bright, overwhelming color of a favorite present. You might recall a single, fleeting image of a smiling face, or the sound of a particular song that was playing in the background. But the full, continuous narrative is likely gone, lost to the mists of time. The act of remembering is not like pulling a file from a computer's hard drive. It is more like being an artist, a painter of memories. Your brain takes the scattered, faded sketches of sensations and emotions that remain, and it begins to reconstruct the scene, filling in the gaps, smoothing over the blurry parts, often using its best guess to complete the picture. And in this delicate, creative process, the past is not merely recalled, it is remade. This profound insight from the field of psychology has completely changed our understanding of memory. For a long time, we believed that memories were stored like perfect recordings, and that forgetting was simply the process of that recording fading over time. But decades of research, much of it pioneered by the psychologist Elizabeth Loftus, have shown us that memory is a far more malleable and reconstructive process. Every single time we recall a memory, we are not just playing it back. Our brain is actively rebuilding it from its constituent parts. And crucially, during this rebuilding process, the memory is vulnerable. It can be subtly, or sometimes dramatically, altered by our current mood, our beliefs, and by new information we have learned since the event occurred. This is known as the misinformation effect. In classic studies, people who witnessed a simulated car crash could have their memory of the event changed by the way they were questioned afterward. If asked how fast the cars were going when they smashed into each other, they would remember the cars going faster than if they were asked how fast they were going when they hit each other. The single word smashed was enough to implant a new detail into the memory of the past. Even more startling is the discovery that it is possible to create entirely false memories of events that never happened at all. Through gentle suggestion and the presentation of plausible but fabricated details, researchers have been able to convince people that they remember being lost in a shopping mall as a child or taking a hot air balloon ride, even when these things never occurred. These are not lies. The people genuinely experience these as their own memories. Their brains have simply done what they do best. They have taken a suggestion and woven it into the rich tapestry of personal history until it feels completely real. This tells us something of profound importance for our dream of time travel. The past that we so desperately wish to return to, the golden-hued landscape of our nostalgia, may not exist in the way we think it does. The past is not a fixed and solid country that we can simply revisit. It is a story we tell ourselves, a narrative that is constantly being edited, revised, and embellished with every telling. The perfect witty comeback you thought of an hour after an argument might, years later, feel like the words you actually said in the moment. The painful awkwardness of a first date can be softened over time into a charming, funny anecdote. We are all, in a sense, unreliable narrators of our own lives. And so, we must ask ourselves a gentle, humbling question. If we could somehow build a machine and travel back to that 5th birthday party, would we even recognize it? Or would we find ourselves in a place that feels subtly wrong, a reality that doesn't quite match the cherished, polished version that has been carefully curated in the imperfect archive of our minds? Would we find that the past we were searching for was never a physical place at all, but a feeling, a dream we constructed long after the moment itself had dissolved? Perhaps the arrow of time is not just a law of physics, but a law of psychology, protecting us from the dissonance of a past that could never live up to our own beautiful, flawed recreation of it. But maybe this arrow is etched even deeper, not just in our minds, but in the very cells of our bodies. Look closely at the back of your own hand. Notice the fine lines that cross the skin, a delicate and unique map of your own journey through the years. Or think of a great, ancient tree in a quiet forest. If you were to see a cross-section of its trunk, you would see a beautiful, concentric pattern of rings, each one a silent record of a year's growth, a story of sun and drought, of warmth and cold. These are stories written by time, and they are stories that can only be read in one direction, from the center outwards, from the past to the present. Life itself, in its every form, seems to be a testament to the forward, irreversible march of time. The universe may have an arrow of time written in the language of physics, but life has its own, written in the language of biology. A seed sprouts, a stem reaches for the light, leaves unfurl, a flower blooms in a brief and glorious burst of color, and then, inevitably, the petals wither and fall, returning their substance to the earth. It is a beautiful, poignant, and irreversible cycle. This biological arrow of time is not separate from the physical one we have already discussed. It is its most intimate and profound expression. The second law of thermodynamics tells us that the universe as a whole tends to move from a state of order to a state of disorder, a process known as the increase of entropy. At first glance, life seems to defy this law. Life takes simple, disordered molecules from its environment, carbon dioxide, water, minerals, and through the magic of metabolism, it organizes them into incredibly complex and highly ordered structures: proteins, DNA, cells, and entire organisms. A living being is a breathtaking pocket of low entropy, a small island of intricate order in a vast cosmic ocean of encroaching chaos. But it is only a temporary victory, and it comes at a cost. In order to build and maintain this local order, a living thing must consume high-quality energy from its surroundings, like the light from the sun or the chemical energy in food. And in the process of using this energy, it releases a far greater amount of low-quality, disordered energy back into the environment in the form of heat and waste products. So, while a plant or an animal creates order within itself, it increases the total disorder of the universe around it. Life does not defy the second law. It is a beautiful and complex engine for fulfilling it. And this relentless thermodynamic pressure is what we experience as aging. Aging is simply entropy, taking its slow, inevitable course on a biological level. Over the years, our DNA, the master blueprint in our cells, accumulates tiny errors and mutations from radiation and chemical exposure. Our cells, for the most part, can only divide a finite number of times, a phenomenon known as the Hayflick limit, before they grow old and stop. The complex proteins that act as the molecular machines of our bodies can misfold and clump together, disrupting cellular function. It is the slow, steady process of a highly ordered system, gradually breaking down, losing information, and succumbing to the universal tide of disorder. To reverse this process, to travel backward in biological time, would require more than just a machine. It would demand the reversal of entropy on a cellular level, unscrambling every mutated gene, refolding every damaged protein, and restoring every cell to a youthful state. It would be like asking the ashes of a burnt log to spontaneously reassemble themselves, not just into a log, but into a living, growing tree. Life, then, is not just a passenger that is carried along by the river of time. It is an expression of the river's current itself. Every beat of our heart, every division of our cells, every thought that flickers through our minds is a tiny, energy-consuming act of creating order, an act that pushes the great wheel of cosmic entropy forward. We are not just living in time, we are expressions of its unbreakable, forward march. This march seems absolute, woven into our very atoms. But let us now zoom out, far beyond our bodies, beyond our planet, to the grandest possible scale. What if we look back to the very beginning of the universe itself? Did the clock of time even exist then? There is a question that children and philosophers alike have asked for millennia, a question that seems to push our minds to the very edge of understanding. What was there before the beginning? What was there before the Big Bang? It feels like a question that should have an answer, a story that should have a first page. We imagine a state of silent, empty waiting, a dark and timeless void, before the sudden, brilliant explosion that gave birth to our cosmos. But what if this picture, this intuitive sense of a before, is a beautiful illusion? What if the question itself is like asking what is north of the North Pole? It is a question that uses the language of our world to describe a place where that language no longer applies. Our journey into the nature of time now takes us to the most extreme moment imaginable, the very beginning of time itself. According to our best current understanding of cosmology, the Big Bang was not an explosion in space, like a bomb going off in a pre-existing room. It was the beginning of space, and just as it was the beginning of space, it was also the beginning of time. Before the Big Bang, there was no space, there was no matter, and there was no time. The very concept of before is a temporal one. It requires a timeline on which one event can precede another. If time itself was born in that initial, incandescent moment, then there was no timeline, and therefore, no before. The clock of the universe did not exist, and so it could not have been waiting to start. It is a concept that challenges the very structure of our thought and our language, which are so deeply woven into the experience of a past, a present, and a future. To imagine a state without time is perhaps the most difficult mental feat one can attempt. It is to imagine a state of pure being, without the possibility of becoming. The brilliant physicist Stephen Hawking, in collaboration with James Hartle, offered a way to visualize this mind-bending idea, a concept known as the no-boundary proposal. He suggested that if we could travel back to the very beginning of the universe, we wouldn't find a sharp, violent starting point, a singularity where the laws of physics break down. Instead, the universe would be smooth and self-contained. He used the analogy of the South Pole on the surface of the Earth. If you are at the South Pole, every direction you can point is north. There is no direction called south of the South Pole. It's a point where the normal rules of direction break down, yet it is not a jagged edge or a hole in the world. It is a perfectly smooth part of the globe. Hawking proposed that the beginning of the universe was like that. As you go back in time, closer and closer to the Big Bang, the dimension of time itself begins to behave less like the time we know and more like another dimension of space. Time, in a sense, becomes spatialized. The universe, in this view, did not have a beginning in the sense of a first moment. It simply is, in the same way the surface of a sphere simply is, without having a starting edge. This vision, if correct, transforms our understanding of time from the ground up. It suggests that time is not an eternal, absolute river that has been flowing forever. It is a feature of our particular universe, a property that emerged along with space and matter. It is a part of the fabric of reality, not the loom on which reality is woven. And if time itself had a beginning, if it is a contingent property of our cosmos, then it forces us to contemplate other profound questions. If it can be born, can it die? If it can emerge, can it fade away? And if the nature of time can be so strange and different at its origin, what might happen to it in the universe's most extreme and violent locations? What happens when the fabric of space-time is stretched, not by the birth of a universe, but by the death of a star in the crushing, silent heart of a black hole? Imagine you are in a small boat, drifting on a calm river. The sun is warm, the water is gentle, but in the distance, you begin to hear a low, powerful rumble. The current quickens slightly. You are drifting towards a waterfall, one of unimaginable size and power. As you get closer, you realize there is a point in the water, a shimmering, invisible line. Before you cross that line, you could still, with great effort, turn your boat around and paddle to the safety of the shore. But the moment your boat drifts across that line, no amount of paddling, no engine, no strength you possess could ever save you. The current is now moving faster than you could ever hope to travel. You are caught, and your destiny is to go over the falls. This invisible line of no return is what astronomers call an event horizon, and the waterfall is a black hole, the most extreme and enigmatic object in the universe. It is a place where the river of time itself plunges into an abyss. From a safe distance, a black hole is a simple and serene object, a perfect sphere of blackness, a hole in the fabric of the stars. But as you approach it, reality begins to warp in beautiful and terrifying ways. Let us imagine you are watching a friend, an intrepid astronaut, fall toward one. As they get closer to the event horizon, a strange thing happens. To you, their clock would appear to tick slower and slower. Their movements would become languid, their speech would stretch out, their image would grow dimmer and redder. They would seem to be slowing down, frozen in time, taking an eternity to reach the edge, but never quite crossing it. You would see their entire existence smeared out over infinite time, a ghostly, frozen image at the edge of forever. But for your friend, the astronaut, the experience would be entirely different. For them, time would be passing perfectly normally. They would feel the immense pull of gravity, but they would see their own clock ticking at 1 second per second. In what feels to them like a finite and perhaps very short amount of time, they would sail smoothly and irrevocably across the event horizon. It is a one-way membrane, a door that only opens inward. And the moment they cross it, the nature of their reality fundamentally changes. Inside a black hole, the fabric of space-time is so warped that the roles of space and time are literally swapped. In our normal lives, we are free to move in any direction in space, forward, backward, left, or right. But we are compelled to move ever forward in time, towards the future. Inside the event horizon, this is reversed. A traveler would be trapped in space, unable to avoid being pulled toward the center, but they could, in a strange sense, move through time. But their future, their ultimate destiny, is no longer a direction in time. It is a place in space. That place is the singularity, the heart of the black hole, a point where the star that created it has been crushed to an infinite density. The journey to the singularity is as inevitable as the journey to next Tuesday. It is the end of the timeline, a point where our current laws of physics and our very understanding of space and time come to a complete and utter halt. A black hole is a place where time, as we know it, ends. It is the universe's most stark and absolute reminder of irreversibility, the ultimate one-way journey into oblivion. And yet, is it truly oblivion? Is everything that falls into this abyss lost forever? For decades, this was the accepted picture. But from this point of no return, this edge of forever, a faint and ghostly whisper might just escape. A whisper that carries with it one of the deepest paradoxes in all of modern physics. A puzzle that pits our two greatest theories against each other and questions the very preservation of the past. It is a paradox born from a faint, theoretical glow, a whisper known as Hawking radiation. Have you ever written a letter then, in a moment of regret or caution decided to burn it? You watch as the flame catches the corner of the paper, turning the sharp edges soft and black. The words you wrote, the information they contained, curl into ash and rise as a thin column of smoke. The physical letter is gone, destroyed. But have you ever wondered if the information itself has truly vanished from the universe? A physicist would tell you something remarkable. They would say that if you had a supercomputer of impossible power, and you could track the exact position and energy of every single particle of ash, every molecule of gas in the smoke, and every photon of heat and light that was released, you could, in principle, reverse the process. You could reconstruct the letter perfectly. The information was not destroyed, it was just scrambled, its order and form so thoroughly rearranged that it became, for all practical purposes, unreadable. This idea, that information can never be truly erased from existence, is a cornerstone of quantum mechanics, one of the two great pillars of modern physics. And this very principle leads to one of the most profound and ferocious paradoxes in all of science, a deep contradiction born from the silent, patient appetite of a black hole. The puzzle is called the black hole information paradox, and it arises from a fundamental conflict between our two best theories of the universe. On one side, we have quantum mechanics, which governs the world of the very small. A core tenet of this theory is that information is always conserved. The total amount of information in a closed system like our universe can never decrease. It can be shuffled, hidden, or rearranged, like the words in the burnt letter, but it can never be truly, completely lost. On the other side, We have Einstein's general theory of relativity, our theory of gravity, and the very large. As we have seen, this theory predicts the existence of black holes, objects whose gravity is so strong that nothing, not even light, can escape once it crosses the event horizon. In the 1970s, Stephen Hawking made a groundbreaking discovery by applying the rules of quantum mechanics to the edge of a black hole. He found that black holes are not perfectly black. They should glow, ever so faintly, with a trickle of radiation, which was named Hawking radiation. This glow would cause the black hole to slowly lose mass, and over an unimaginable stretch of time, trillions upon trillions of years, it would eventually evaporate completely, vanishing in a final, quiet puff of energy. Herein lies the paradox. Hawking's initial calculations showed that this radiation was purely thermal. It was random, like the hiss of static on a radio. It contained no information whatsoever about all the things that had fallen into the black hole during its long life. No trace of the stars, the planets, or the astronauts it had consumed. So, when the black hole finished evaporating, all the unique, complex information that it had swallowed would be gone from the universe, erased forever. This was a direct violation of the sacred law of quantum mechanics. It was as if the universe had a grand library containing the story of every particle that had ever existed, and a black hole was a furnace that could permanently burn its books. For decades, physicists battled over this problem. It was a deep crack in the foundations of their understanding. Stephen Hawking himself initially argued that the information was truly lost, a controversial stance that challenged the supremacy of quantum theory. But over time, the evidence began to mount that information must, somehow, be preserved. Hawking, eventually, and famously, conceded his original position, admitting that black holes must not be the ultimate data destroyers after all. But if the information is not destroyed, where does it go? How does it escape? Several beautiful and strange ideas have been proposed. Perhaps the information is imprinted on the two-dimensional surface of the event horizon, like a cosmic watermark, and is then subtly encoded in the outgoing Hawking radiation in patterns and correlations so complex we cannot yet decipher them. Or perhaps the singularity at the center is not an endpoint, but a gateway to another universe, where the information re-emerges. This is not just an abstract, academic debate. It is a question about the very nature of reality and the persistence of the past. Is the universe a reliable keeper of its own history, or can pages from its story be irrevocably ripped out and destroyed? The struggle to solve this paradox has led physicists to a conclusion so strange, so counterintuitive, that it sounds like it was lifted from a dream. It is the idea that the solid, three-dimensional world we see around us might be an illusion. Take a look at the credit card in your wallet, or a modern banknote. You will likely find a small, shimmering square of silver, a security feature that displays a fascinating illusion. As you tilt it back and forth in the light, a three-dimensional image appears to float within it, a bird, perhaps, or a face. You can see it from different angles. It has a sense of depth and solidity that seems impossible for a flat sticker. This is a hologram. All of the complex information required to create this convincing three-dimensional illusion is entirely encoded on a simple, two-dimensional surface. Now, hold that thought and expand it to the grandest possible scale. What if our entire universe, with its 3 dimensions of space and its 1 dimension of time, with its unfathomable depth and its countless galaxies, works on the very same principle? What if we are all just living inside a grand, cosmic hologram? This breathtaking idea, known as the holographic principle, is one of the most significant and mind-bending concepts to emerge from the struggle to solve the black hole information paradox. The first clue came from a simple question: where is the information of a black hole stored? Physicists Jacob Bekenstein and Stephen Hawking discovered something extraordinary. The amount of information a black hole can contain does not depend on its 3-dimensional volume, as one might expect. Instead, it is proportional to the 2-dimensional surface area of its event horizon. It was as if you tried to store information in a room and found that the storage capacity depended not on the size of the room itself, but on the square footage of its wallpaper. This was a profound hint that perhaps reality is not what it seems. Physicists like Gerard and Hooft and Leonard Susskind took this clue and developed it into the holographic principle. It proposes that all of the information that makes up our perceived three-dimensional reality is actually written on a distant, two-dimensional boundary surface that surrounds us. The universe, in this view, is like a movie being projected on a screen. We are the characters in the movie, experiencing a world of depth, motion, and the passage of time. But the source of this reality is not within the movie itself. It is on the film, the two-dimensional surface where the information is stored. This means that space, and even time itself, might not be fundamental aspects of reality. Instead, they could be emergent properties, a projection of a deeper, timeless, and spaceless reality of pure information that exists on some cosmic horizon at the edge of the universe. The familiar world we inhabit, with its solid objects, its vast distances, and its steady, flowing river of time, might be a beautiful and elaborate holographic illusion. Our feeling of moving through space might just be the result of correlations and relationships in the underlying code on that distant surface. This theory is not just a wild speculation. It is a serious theoretical framework that elegantly resolves the information paradox. The information that falls into a black hole isn't lost inside a three-dimensional volume. It is simply scrambled and stored on the two-dimensional event horizon, perfectly consistent with the holographic nature of the universe. So, let us pause for a moment and allow the sheer wonder of this idea to settle. Are we the characters in a grand cosmic hologram? Is our profound feeling of depth, of movement, of the irreversible passage of time simply an elaborate illusion, a ghostly projection from the true reality that lies on the boundary of our cosmos? It is a vision of the universe that is both deeply humbling and strangely comforting, suggesting a hidden layer of reality, a different way of being, that underpins everything we know. This has been a vast, cosmic perspective, a journey to the very edge of physics and reality. But now, let us bring our focus back from the edge of the universe to the intimate world within ourselves. Let us set aside the impossible physics and the cosmic projections. If, by some magic, we were simply handed a key to the past, what would be the true cost of using it? What would be the burden on the human heart of knowing what comes next? If you were offered a peek into the future, just for a moment, what would you want to see? Perhaps the winning lottery numbers for next week, a chance to secure your family's future and live without financial worry. It is a tempting thought. But what if the offer was all or nothing? What if, along with the lottery numbers, you also had to see every sad moment, every painful loss, every unexpected heartbreak that awaits you and those you love? Would you still take the offer then? To know the future, or to be able to rewrite the past, is to carry a burden that the human mind may not be built to bear. It is to trade the precious gift of the unknown for the heavy cloak of certainty. And in that trade, we might lose something far more valuable than we could ever hope to gain. Imagine watching your favorite movie for the second time, a movie with a deeply moving but tragic ending. The first time you watched it, you were caught up in the story. You felt the suspense. You hoped for the characters. You were surprised by the twists and turns. But the second time, the experience is different. The suspense is gone, replaced by a kind of gentle, knowing sadness. You notice all the small moments of foreshadowing, the brief flashes of happiness that you now know are fleeting. You see the characters making choices that will lead them to their inevitable fate, and you wish you could call out to them, to warn them, but you can only watch as the story unfolds exactly as you know it will. Now, imagine living your entire life this way. Every conversation, every first meeting, every joyful surprise would be tinged with the melancholy knowledge of what is to come. The authentic, spontaneous joy of discovery would be replaced by the quiet performance of a part you have already memorized. Neuroscientists use the term chronesthesia to describe our remarkable ability for mental time travel. It is the form of consciousness that allows us to remember our past and to project ourselves into the future, to plan, to hope, to dream. This ability is central to our sense of self, to our identity. Real time travel, the ability to physically revisit and alter the past, would inflict a terrible wound on this delicate mental faculty. It would create an unbearable cognitive dissonance, a constant conflict between the life you are reliving and the memory of the original timeline. Furthermore, the very nature of human emotion would be transformed. Regret would no longer be a passive, reflective emotion about a past that cannot be changed. It would become an active, agonizing tool. You would be haunted not by what was, but by an infinite number of what-ifs that you could actually implement. Should you go back and unsay that unkind word? What if that prevents you from learning a valuable lesson in humility? Should you go back and prevent a small accident? What if, in doing so, you unknowingly set in motion a chain of events that leads to a much greater tragedy? You would become the curator of 1,000 branching timelines, a god of your own history, and the sheer weight of that responsibility, the paralysis of infinite choice, could be enough to break the soundest of minds. And so, we must ask, is our inability to change the past truly a curse, or is it, perhaps, a fundamental blessing? Is it the very thing that allows us to live authentically in the one present moment that is truly ours? This irreversibility is what gives our choices weight and our actions meaning. It is what allows us to learn, to grow, to forgive ourselves and others, and to find the strength to move on from sorrow. Perhaps the arrow of time is not a prison, but a protective sanctuary, a gentle law of the universe that shields us from the unbearable burden of knowing everything. Perhaps the stories we tell ourselves about time travel in our books and our films reveal less about the physical possibilities of the past and more about the deep and poignant yearnings of our present. We all dream of a second chance. It is one of the most deeply human desires, a quiet wish to turn back the clock, to have a do-over, to find the one person who can give us a clean slate. We want to unsay the hurtful word, unmake the foolish mistake, take the road we passed by. Why is this desire for a second chance so universal, so powerful? It is the myth that whispers to us that our lives could be perfected, if only we were given the chance to edit them. Imagine you are an author writing a novel. You write a clumsy sentence, you can delete it. You create a plot hole, you can rewrite the chapter. The goal is a kind of polished perfection, a story with no flaws. But a human life is not a manuscript. Its beauty and its meaning are not found in its perfection, but in its unedited, irreversible reality. The mistakes, the crossed-out passages, the moments of regret, these are not flaws in the story. They are the story itself. They are what give it its texture, its depth, and its humanity. The vast library of stories we have created about time travel almost always revolves around this central theme of regret and redemption. A hero travels back in time to save a loved one, to prevent a global catastrophe, or to fix a personal failure that has haunted them. These stories are a beautiful reflection of our deep-seated need for a sense of control over a world that is often chaotic, and a life that is fundamentally irreversible. They are a comfort, a fantasy that tells us that nothing is ever truly broken beyond repair. But some streams of philosophy offer a different, and perhaps more powerful, perspective. They suggest that our choices gain their profound weight and meaning precisely because they are irreversible. This is what forges the muscle of responsibility and what makes our lives authentic. If you could undo every mistake, your choices would become weightless, like a game with infinite lives. There would be no courage, because there would be no real risk. There would be no forgiveness, because nothing would be truly final. The philosopher Friedrich Nietzsche offered a powerful thought experiment to confront this idea. He called it the eternal return. He asks you to imagine that a demon were to creep into your loneliest loneliness and say to you, "This life, as you now live it and have lived it, you will have to live once more and innumerable times more, and there will be nothing new in it, but every pain and every joy and every thought and sigh must return to you all in the same succession and sequence." How would you react? Would you throw yourself down and gnash your teeth and curse the demon? Or would you reply, "You are a god, and never have I heard anything more divine"? Nietzsche's challenge is not to wish for a different life, but to live the one you have with such intention, such purpose, and such love for your own fate that you would joyfully embrace its eternal repetition, flaws and all. This way of thinking reframes the irreversible nature of time not as a limitation, but as the ultimate call to action, to live more fully, more bravely, and more intentionally in the one precious, uneditable present that we have. The dream of reversing the past, then, is the dream of achieving a perfect life. But perhaps a truly perfect life is not one that is free from mistakes, regrets, and sorrows. Perhaps a perfect life is one where we have learned to find the beauty and the meaning in our own unique, unedited, and irreversible journey. It is a life where we have learned to say yes to every moment, not because it is always pleasant, but because it is always ours. We have wandered together through the most fantastic landscapes of the human imagination and the furthest frontiers of modern science. We have walked through the curved dreamscapes of Einstein's relativity, sifted through the shimmering chaos of the quantum foam, and explored the quiet, dusty archives of our own fallible minds. We have asked the universe if its most fundamental law, the relentless forward march of time, could ever be broken. And now, as our journey nears its end, we must ask, what have we found? Is the river of time truly reversible? Imagine we are in a vast, quiet library, the air still and smelling of old paper and dust. Over the course of our journey, we have pulled many different volumes from these towering shelves, books of physics, of biology, of psychology, and of philosophy. As we lay them open on the great wooden table, a single, coherent story begins to emerge. A gentle but firm consensus, written in the varied languages of these different disciplines. The book of physics tells us a story of immense, almost unimaginable, difficulty. It shows us the beautiful, theoretical possibility of a wormhole, a gateway through time. But then, it tells us that the price of admission is a substance, exotic matter, that would require the energy of billions of stars to create, and may be fundamentally impossible to exist in a stable form. The sheer scale of the engineering required to bend space-time to our will is so far beyond our capabilities that it remains firmly in the realm of myth. The book of thermodynamics tells a simpler, and perhaps even more powerful story. It speaks of entropy, the universe's unyielding tendency to move from order to chaos. This is the second law, and it is perhaps the most robust and well-tested law in all of science. Every star that shines, every plant that grows, every breath you take is a part of this grand, irreversible unfolding. To travel backward in time would be to reverse entropy, to unscramble the egg, to reassemble the shattered glass. It would be to swim against a cosmic current so powerful that it has governed every moment of the universe since its very birth. The book of logic whispers to us of paradoxes, of the logical knots that tangle any attempt to alter the past. These paradoxes have led many physicists, including Stephen Hawking, to believe in what he called a chronology protection conjecture, the idea that there must be a yet undiscovered law of physics that explicitly forbids time travel to the past, a kind of cosmic censorship that protects the coherence of reality. The universe, it seems, does not appreciate a story with a plot hole. And finally, the books of psychology and biology remind us that, even if we could make the journey, the past we seek is not what we think it is. Our memories are flawed, creative reconstructions, and our bodies are expressions of time's forward flow, records of its passage written in our very cells. The scientific consensus, then, is a quiet but clear one. While some esoteric equations might leave a tiny, theoretical window open, the physical, logical, and thermodynamic barriers are so immense, so fundamental, that the dream of travelling to the past is likely to remain just that, a dream. The arrow of time appears to be unbreakable. The universe seems to have a profound and unshakable bias for the future. It is a system designed for unfolding, for becoming, for novelty. It is a story that is constantly being written, not one that is meant to be reread. And yet, even after all of this, the human heart continues to yearn. The dream of reversing the past is too powerful, too poignant to be dismissed by equations alone. If science tells us the door to the past is locked and barred, then we are left with a final, and perhaps the most important, question of all. If we cannot step back into the past, how can we learn to make peace with it? Take a gentle breath. Feel the cool air as it enters, and the warmth as it leaves. Feel the slow, steady rhythm of your own presence in the world. In this simple, quiet moment, you are a time traveler. You are journeying into the future at the most constant and reliable speed there is. 1 second per second. This journey requires no machine, no exotic matter, no violation of cosmic laws. It only requires you to be here, now. For all our grand and searching questions about reversing the past, perhaps the most profound answer has been with us all along, waiting patiently in the stillness of the present moment. Perhaps the true mastery of time is not found in the quest to control it, but in the gentle art of inhabiting it. As you rest here, feeling comfortable and safe, let the world outside soften and fade. Feel the gentle weight of a warm blanket. Listen to the soft, distant sound of the city settling down for the night, or perhaps the quiet murmur of rain against the window pane. This is the only place you can ever truly be. Our entire journey has been a search for a way back. But what if the concepts of past and future are not destinations on a map? What if the past is not a country we can visit, but rather a vast and precious library of memories and lessons that exists only within our own minds? It is a resource we can draw upon for wisdom, for comfort, for gratitude, but it is not a home we can return to. And what if the future is not a predetermined destination waiting for us, but a great, misty ocean of pure potential? An ocean that we navigate with the rudder of every choice we make in this moment, right now. The only place where we have any power, the only place where life is actually lived, is in the gentle, shimmering sanctuary of the now. This is not a consolation prize for our inability to travel in time. It is the ultimate truth of the human experience. Spiritual traditions and modern psychological practices like mindfulness have understood this for thousands of years. They teach us that our suffering often comes from mentally living in the past, burdened by regret, or living in the future, crippled by anxiety. The path to peace is always found in returning our awareness, gently and without judgment, to the simple, tangible reality of the present. We began this journey together by asking if we could really reverse the past. But perhaps, after all our wandering, we can see that the better question was this: why did we want to in the first place? The answer to that question is a compass. It points us directly to what is most important, to what our hearts truly value. Our yearning to revisit a moment of lost love is a compass that points to the importance of cherishing the love that is in our lives today. Our desire to undo a mistake is a compass that points to the importance of compassion and forgiveness in our lives today. The past is not a destination to be reached, but a guide that can help us navigate a more meaningful and wholehearted present. The real secret of time is that it is not a problem to be solved, but a gift to be received, moment by moment by moment. Thank you for joining me on this gentle journey. I hope it has brought you some comfort, some wonder, and perhaps a sense of peace. If you've enjoyed our time together, please consider leaving a kind comment or liking and subscribing to the channel. It helps this quiet corner of the world reach others who may be searching for it. For now, though, all that is left to do is rest. May your mind be calm, may your body be at ease, and may your sleep be deep and dreamless. Good night.